Forces in Action Project on the Sport of Bowling. Project by Daisy Davis, Grace Rhines, and Brandon Carreras.
Newton's first law. An object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an outside force. How Newton's first law relates to bowling. The bowling ball on its rack is in a natural state. It is not moving because there is a balanced amount of forces acting upon it. The bowling pins are also in a natural state and not moving because they are acted upon by balanced forces. Both the bowling ball on the rack and the bowling pins on the lane are not moving because balanced forces of the normal force and the force of gravity. When the bowler releases the bowling ball down the lane, it has been enacted upon by the force of the person, so it leaves a natural state. The bowling ball is then in a state of inertia and would continue moving forever at a constant speed. Once the immediate acceleration of the release is over, the bowling ball moves at a constant velocity down the 60-foot lane because of the balanced forces. It does not slow down because friction is negligible since there is a coat of wax called paste wax evenly layered on the lane. The bowling ball comes to a stop once it hits the pins at the end of the lane, also causing the bowling pins to move. The bowling pins at the end of the lane move and leave a state of nature because the unbalanced forces with the bowling ball.
Newton's second law. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. In bowling, the more acceleration the bowling ball has, the harder the ball will hit the pins. The acceleration also depends on the mass of the bowling ball that is being thrown. The maximum value of mass of a bowling ball is 7.26 kilograms. The mass of the bowling pins is 1.5 kilograms. Acceleration equals force divided by mass, where force is dependable on the strength of the bowler. The force of gravity on the bowling ball is 71.15 newtons, and the force of gravity on the pins is 14.7 newtons.
Newton's third law. When objects exert forces on each other, the forces are equal in magnitude and opposite in direction. These objects are called third law pairs. When the bowling ball hits the lane is affected by the force of the bowling ball on the lane, and the bowling ball is affected by the force of the lane. This would cause the bowling ball to accelerate on impact. It would slow to a stop and accelerate in the opposite direction as it bounced. The lane would not accelerate because it would be balanced by the other forces around it, such as the earth underneath it.